Hi guys and welcome again. Today we are doing grade 12 maths paper 1 and this is question 5 from the 2025 November paper, and we are given graphs f of x equals ax squared plus bx plus c, so that must be the parabola, and we are given negative 4 over x minus 3 plus 8, which is the hyperbola. So to begin with, let's just look at some of the stuff that we are given here. Okay, so I'm going to just highlight in pink the parabola. Okay, so it's a sad face graph, so we know our a there is going to be negative, and we are given the hyperbola. Let me do that in green. Just that when I refer to the graph, sometimes I can just refer to them in terms of the colors, which might help a little bit. Okay, so that's our g of x, and we're told the turning point. It's been written there 3 and 8 by the student who sent me this paper, who asked me to go through it. So I'm going to do this question, and I can already see that he got this one right, 3 and 8, because that would be the asymptotes based on our g of x there in green. So well done. And yeah, let's look at now the first question, which is to write the domain of G. Okay, so what I'm going to do actually before I start that is, because he's done the 3 and the 8, I'm going to just go over why that's true. So we know that for a hyperbola, we have, it would be y equals, let's just make this a bit bigger. Y equals a over x minus p plus q, right? Where p and q are the asymptotes. So let's start with 8. So I'm going to do 8 there in red. Okay, so there it says 8. So that means that we have this asymptote at y equals 8. And then we have x equals negative 3. So we have another asymptote at x is equal to 3. Okay, so x is equal to 3. And that's why, yes, this is indeed 3 and 8. So that point P is correct. That may be one of the questions coming up. Let's look at the first question, which says write down the domain of G. Okay, so the domain is all the possible x values. So it can be everything except as x equals 3. So it'll be x is, oopsie, it'll be x is an element of real numbers, but x cannot equal 3. Okay. X does not equal 3. You can also do it in a different way if you wanted to go from negative infinity to 3 and from 3 to infinity like that with open brackets. That's another way of doing it. But I think the easier way is just to say x is real and x is not equal to 3, and that gives everything. All right, now the range of f. The range of f. Okay, so this is why we needed actually the 3 and the 8, because the range of f is all the possible y values of our pink graph. And so we see that that is everything below 8, right? So we know that then y is just less than or equal to 8. Okay, because we have our turning point there at 3 and 8. All right, question 5.3 says determine the values of x for which g of x is greater, less than f of x, right? So where is the pink bigger than the, where is the pink larger than the green? So where is the pink above the green? So we know that the green one would extend all the way here until it gets to 3. So it's not there. And so the pink is just bigger. I'm going to do this in, we'll do it in yellow over here, right? Oh, that's not yellow. We'll do this in yellow, over here and over here. And so what are the x values there? The x values are 5 and 3. So it's where x. Now, because there's an asymptote at x equals 3, it does not include 3. Okay, even though it says greater than and equal to. So it's going to be from 3 to 5x. It's going to be greater than 3, but it is allowed to be equal to 5 because we can see that touch at that point. But at this point here, it does not. The green does not exist at 3. So you cannot say that it's greater than or equal to. All right, and then where is f of x bigger than 6? Okay, so where is it bigger than 6? So where is the green one bigger than 6? So if we look here, there is 6 there, right? And so it's bigger than 6 between 5 and then another value on this side. Well, we can do symmetry, right? Because we know that this is 3. So from 3 to 5 is 2. So then it'll be from 3 to 1, right? Because this distance here is 2. And so it'll be 2 there because this is a nice symmetrical parabola. And so it'll be bigger where x is between 1 and 5. Okay, the next one says, show the equation of the parabola. Okay, now when you look at the equation of the parabola, we look at what are we given? Well, we're given, because of the fact that the turning point is on these asymptotes, which we already know, we're given the turning point as well as a point. And so then it's a natural option just to put in the turning point formula. So I'm going to do this slightly higher and in what's going to be a nice one to see. Okay, I'm going to do it in this one. Should be good. This dark purple. So 5.4. Hopefully you can see that. Let me just make this a bit bigger. So 5.4. We want to show the equation. So what we're going to use is the turning point formula. So I'm just going to write that just as a reminder, which is a x minus p squared plus q, where p and q are the turning points. So those would be 3 and 8. Okay, so p is the x value, q is the y value. So we can now write that in. And the idea here is that this is y equals 2, by the way. We're also going to sub in another point, 5 and 6, because those are also lie on the parabola, and so we have an x and a y. So yeah, I'm going to put it all in one just to save a bit of time. So our y value that we're going to substitute is a point on the graph, which is 6. Our a is what we want to try and figure out. Our x value is 5. Our turning points are 3 for the x squared plus q is 8. And so we get 6 equals 5 minus 3 is 2. 2 squared is 4. And so we get 4a plus 8 going to the other side. I'm just going to make that minus 8 plus 8. So I can divide by 2 here, and I'm going to get a is equal to negative a half, which is what we want there. Now we can simply write it out again, but times it out. So negative a half, and then it'll be x minus 3 squared plus 8. And now when we times this out, we'll get negative a half x squared minus 6x plus 9 plus 8. And so we'll get negative a half x squared plus 3x plus 7 over 2 when we do that. And so that is shown. Okay, so that's 5.4. Now they want the length of MT. Okay, so when we look at M, we know that that is where the parabola hits the x-axis, and T is where the green one, the hyperbola, hits the x-axis. So if I figure out those two, the distance will be just easy to calculate. So let's start with M. Okay, so I want to find the x-intercepts. Okay, so I'm going to say negative a half x squared plus 3x plus 7 over 2. Now, the easiest thing to do here, because we're going to make this equal to 0 to get the x-intercepts, I'm doing this in red, 5.5. Sorry if this is tricky on the eyes. Let me switch to black. I'm going to multiply by negative 2. So I'm going to get x squared plus 6x when I times this by, I'm going to get the negative 7. That's a bit easier now because I now know that I've got a negative and it's more positive. So it'll be positive 7 and x minus 1. And so x is equal to negative 7 and x is equal to 1. Okay, that does not make, it must be negative 1. It must be negative 1. Okay, so that's 7 and that's negative 1. Okay, I made a slight error there somewhere. Possible, oh, because, yes, because we take out a negative. Yes, so that'll change the roots. Okay. All right, so we can change this to, that'll be minus 7 and plus 1. And plus 1, and so we'll get x equals negative 1 and x equals 7. All right, now we have yes, because when we times the 6, yeah, so when we times this, so just to clarify, when we times, we'll get a negative 6x, and so it'll be more negative. Okay, and we can see that here because look, the 3 and the 7 will both have the same signs. Okay, so always important to check on your graph, does the question make sense? Because even if you're doing this for a long time like me, you can still make mistakes, but you can correct them in the exam. Make sure you still get the points. All right, so that value here is negative 1. Now, if we find t, we'll be able to get the distance. So now t is going to be where the green graph is equal to 0 as well. Okay, so I'm going to do that up top. Yeah, sorry about the, yeah, I can do it at the bottom. So it's just, okay, negative 4 over x minus 3 plus 8. Negative 4 over x minus 3 plus 8. Negative 4 over x minus 3 plus 8 equals to 0. Take it across. I'm going to get 4 over x minus 3 equals 8. If I and then I times everything by x over 3, so I'll get 8x time by x minus 3, so I'll get 8x minus 24 equals 4. And so then I'm going to get 8x equals 32. And so I'm going to get x is equal to 4. So t, that makes sense because it's going to be between 5 and 3. So yeah, we think 4 is pretty good. Good one there. So it's from negative 1 to 4, right? So therefore, mt is equal to, I'm just going to put, you may not have seen this, but the absolute value of negative 1, because we want this unit, this length, and we don't want to subtract the 1 because that's going to add to the distance. So for those of you who've done AP maths, negative 1 absolute value gives you 1, and then it'll be plus 4 and it'll be 5. Okay, but you don't have to put absolute value of negative 1. You can just put 1 plus 4 is equal to 5. Don't worry about that. I'm just being just technical there. Okay, determine the equation of f at the tangent d. Okay, so what is f? The tangent. The tangent is going to be the slope, right? So we want the slope at d. So I'm just going to draw that, and then I'm going to go down and solve. Okay, so that's going to look, that's going to be along here. So it's going to have a slope. Now we can get the m by getting the derivative of f of x, right? And then we can simply sub in this 5 and 6 as points into our graph to get c. Okay, so what I like to do when I'm asked to do a straight line is to use my, I call it my North Star, my guiding light in these questions, and that is y equals mx plus c, and then figure out what do I need, right? I need the m first. So I'm going to say f dash of x, right? So f dash of x is equal to 2 times negative a half is negative 1x plus 3, the derivative of 3x is 3. And I'm going to now what do I need? I need the slope at the point where x is 5, right? Because it's a tangent at d. So I can say f to the dash of 5 is equal to negative 5 plus 3, which is negative 2. Does it slope down? Yes, it does. So that makes perfect sense. Now, I can do the negative 2. I just want to make sure I put that in right. 5. Yep. Okay, and now I can sub in another point to get C. So my M is negative 2, and then I'm going to sub in that 5 and 6, right? That's 5 and 6 that I had over there. I'm running out of colors to use. Let's use this light green. So this 5 and 6 there, I'm going to just sub in, right? So Y is 6, X is 5, and that's going to give me C. I'm almost at the finish line, and so C, this goes across and gives me 14, because 6 plus 10 is 14. So then Y is equal to negative 2x plus, I wrote 10, but it's actually 14. And let's see, does that make sense? Yes, it's going to go up, 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 all the way past 8, and somewhere up to there about 14. Okay, so there we go. That is question 5. Next one is question 6. You can take a look if you want and pause the screen, try and do that. As I said, I hear everyone saying, please smash that like button. Don't want you to break your keyboards. Just gently click on that subscribe button and comment. Did you find this paper easy? Did you find it difficult? What would you like help with next? Just giving you ideas, really. I need the comments, and I really appreciate when you guys give compliments too. It really makes my day. I'm thirsty for those compliments. Cheers, guys.